wanted to do a quick little session about my Fisk-AI harness, and specifically around agent to agent. I have here an agent that manages NATS JStream consumers, and using the word manage a bit, it's not really managing, it's just making information available. These are simply read-only operations. And it's a contrived example of what I'm trying to show is that here is an agent that only focuses on consumers, and we may have another agent that focuses on streams. In other worlds, you can imagine you have one agent that manages a cluster of Redis servers, and you have another team who manages monitoring, and they would have an agent running that exposes monitoring tools, or that can run prompts against the monitoring background. And so you have these two agents and two zones of responsibility. And there could be authentication, authorization, auditing. Trust must be established before these agents can communicate, and that will come when I build these kind of things on the Choria Protocol that has all of that. For now, I have a very simple NATS-based agent-to-agent system. And so if we look at the agent configuration here, we can see I specifically choose to expose agent-to-agent. And MCP, I'm going to shut down the MCP bits here because it's not necessary. And I run the NATS binary, and it extracts from the NATS binary just these two tools. And so if I start this A2A, we can see it's going to start, server is running, it's listening on certain subjects, and it's exposing these two tools. On the other hand, I have an agent that does streams, and it has no consumer capabilities, but it imports tools from a remote agent. And so I can import the tools, or I can input the full prompt. If I'm pulling in a full agent-to-agent workflow where all of the kind of thinking and everything communicates between the two agents, that's possible. In this scenario, all I want is to just use the tools. And so the tools would be reached over a normal request reply, RPC call, meaning no LLM is involved in the actual tool invocations, but I could expose the full agent prompt interface, in which case it will be full A2A call, and the A2A call could be either just kind of like a tool, take my prompt, give me the answer, or it could be a full interactive A2A flow where you will see the thinking and the responses and all the steps as it goes through solving the problem. The Choria A2A protocol supports both of those. And so, again, here I'm doing NATS. I'm focusing only on streams. I'm putting just a couple of stream commands. And if I do here, Fisk-AI info, we'll see that, it's a bit big. Here we go. We'll see there's the stream tools. But what we'll also see is we have the consumer tools, and they come from a source called NC. And we can see here that we have a remote tool host, that's consumers, it's reachable, it's pulling in two tools. And then I can do Fisk-AI run for the, let me just summarize the consumers for the stream of the most messages. And so first it has to figure out what is the stream of the most messages. You can do that locally with no help from a other agent. But summarize the consumers means it's going to have to figure out what the consumers is for the stream. And on its own, it doesn't have consumer capabilities, right? And so for that, it has to go and call out to the consumer agent via an A2A protocol. So let's see. So it's going to do the stream report. It can do this locally. Now we can see it's doing tool calls against the remote. It's listed the consumers and it's getting consumer info for each consumer. And here's a summary of what's going on there. And so at the end we can see there's total LLM calls was 4, total tool calls were 4, and the remote tool calls were 3 of the 4. And so most of it went to the consumer side of this conversation. And so this is a agent-to-agent cooperation. As I say, down the line, there's going to be. For now, I've focused on the message flow, the message content, and so forth, and I've hooked it onto a Bear and Nats transport. Once that is hooked onto Choria transport, standard existing Choria transport, the A2A calls will be done subject to authentication, authorization, policies, auditing, all this kind of stuff. And the two teams will be able to say, we allow that other team to communicate to us. There's going to be a service account or a role account or something along these lines that gives the stream capability to call out to other A2A agents, and the receiving A2A agent will approve or not those calls. And so all I have to do is plug this into the Choria protocol, and we have all those concepts covered. But really what I'm showing at this point is just the basic A2A capability of remote tooling. And I can do things like also Fisk-AI discover Nats consumers, I think it's called. Let's see. Yes, and so it found ones. These are the subjects. These are the tools that's available, and we even get the tags so that we can do things like I can say to it, if there's any impact RW tools before that tool is called, do a prompt, a yes, no, always kind of prompt that you've seen in Claude. This harness supports all of that stuff, and it's based on how the tools are tagged, and you can configure which tags are what for your particular use. Anyway, so just that. I just wanted to show the A2A working. I've also done something else that's quite interesting actually. Let's say trace lm.json, and it's going to trace this entire session into a file that's JSON lines. LLMs are extremely inefficient. It's not good for your blood pressure to look at a full trace of an LLM conversation. But if I say cat LLM trace like JQ, let's see, session starts. Here comes the prompt. Here comes the system prompt and schemas for the tools, and you'll see every interaction and tool call and results and all this kind of stuff is there. And so we have a full trace of every session if you enable that feature. That's it so far. I have to implement the A2A protocol that exposes the full prompt, but the protocol that I've implemented, it's modeled quite closely to how Anthropic does their API. So same kind of distinctions around message kinds of thinking, and all that kind of stuff. I haven't gone too deep down the line of designing that thing. It's kind of the first thing that works at this point. And really that's the background for almost everything I'm doing with the Fisk-AI tool. The longer game plan here is, instead of using CLI tools that I'm using here, these calling into the NAT CLI, let's say, I want to run this in large workflow systems where a company has millions of machines, and within that millions of machines is a team with maybe 20, 30, 50, 200 machines, and they want to be able to define long-running background agents. And the tools that they will expose, instead of random CLI stuff, would be workflows that was developed on top of this giant workflow engine where there's already trusted workflows on how you manage infrastructure, how your team's already doing it today. Expose those tools into a prompt, hook them onto events, and so we can come up with really deterministic ways to manage infrastructure. You get a page, the particular agent wakes up, it understands your tools that you use day to day for managing your infrastructure. You've written to it how your stuff is shaped, how you like to work, how you like to investigate and triage issues. And by the time you get to Slack, you have a researched outage. The thing has pulled in information from other agents, like the monitoring team or the networking team, or log aggregation teams, etc., by doing A2A calls. And you get to your computer in the middle of the night. The Slack incident room the AI has put a researched triage there saying this is what it thinks the problem is. And maybe you have some read-write tools that might be doing something like a rolling restart. The agent would then, with human in the middle, prompt you, would you like me to restart the servers? And you can say no, and you can do something else. But it's that I think it's the kind of early triage I want to provide. And so I want for teams to be able to make 1 or 10 or 50 even background agents that's configured in this manner, obviously on a web interface, and they sit within the event stream and within the general things that happens about this machine, and it uses very deterministic tools to sit and interact with your fleet. So you have AI operations that's properly guardrailed, properly deterministic. That's a long-term goal, and so I'm really developing this CLI. I think it's useful, but to explore how the libraries and stuff would work, that allows me to plug this kind of behavior into the large workflow systems we have developed with Choria. There's some startups working in this space, and some Choria users have homegrown workflow systems, and I'm looking to provide a capability there for that. Anyway, just a little bit of background and a short demo on the A2A stuff. Thank you very much.